In this video, we are going to look at simplifying square roots using the quotient property. So the quotient property of square roots says if you have the square root of a quotient or fraction, a over b, you can break that up into the square root of a over the square root of b. As long as a and b are non-negative, so positive, real numbers, and b is not equal to 0 because we cannot have 0 in the bottom of the fraction. It's considered undefined. So let's look how we have used this already. Already we've done some problems where we had something like the square root of 1/9. And we said, well, that was the square root of 1 divided by the square root of 9. The square root of 1 is 1, and the square root of 9 is 3. And we could test that. If we take 1/3, that answer, and we squared it, we'd get 1/3 times 1/3, which is 1/9, which is what we started with inside the square root. So we want to just expand our use of that quotient property today and do a few other examples. So the next one I would like to look at is the square root of 75 over 12. Well, thinking about kind of order of operations, in general, anytime we have something like a fraction inside of another operation, in this case square root, we always like to simplify that fraction if we can. And in this case we can. Both 75 and 12 are divisible by 3. So we want to simplify or reduce the fraction before we go any further. So 75 divided by 3 is 25, and 12 divided by 3 is 4. Once the fraction is fully reduced, now we'll use the quotient property, and it becomes the square root of 25 or the square root of 4. And now we can evaluate. Square root of 25 is 5, and the square root of 4 is 2. Let's do an example with some variables. What if I had the square root of x to the 10th over x to the 16th? So in this case, underneath that radical, I have a fraction using the quotient rule. I have more x's on the bottom, so my x's will end up on the bottom. And 16 minus 10 is 6. So I'll have x to the 6 on the bottom, and on the top there'll just be a 1 left. Now that I've simplified the fraction, I can use my quotient rule and then evaluate the numerator and the denominator. So let's look at one more, and I want to look at one that just has a little more going on. So this last one will be the square root of 180 x to the 13th over 64 x squared. So my first step again is to look inside at the fraction and say, can I simplify the fraction itself? So I look at the numerical part, 180 and 64, and I start reducing, and as I go it turns out that they can both be divided by 4 to reduce down. And I end up with 45 on the top and 16 on the bottom, and that fraction does not reduce any further. As for the variables, I have x to the 13th on top, x squared on the bottom, so I have more x's on top, and I subtract 13 minus 2 and get x to the 11th. Now I'm ready to use my quotient property, and I'll split it up into the square root of 45x to the 11th on top and the square root of 16 on the bottom. The bottom I can evaluate nicely. Square root of 16 is 4. The top, however, has two things going on. One, I notice that the number 45 is not a perfect square. And I notice the variable has an odd exponent. So I'm going to have to split both of those up. So I'm going to look at the number first. I'll take that number 45. I'll start looking at its factor pairs till I find a perfect square as a factor. So 1 times 45, let's see, 3 times 15, no perfect squares yet. And 4 doesn't work. 5 times 9. All of a sudden, as I'm going down and looking at the largest to smallest factors, I find a perfect square factor. So I'm going to break that 45 up into the perfect square of 9 times 5. Now, we've seen before when we have x to an odd number, we break that down into the closest even that is below that odd number. So 11, the closest even below 11 is 10, and then I'll still have times x to the first. So I split the top up, but you'll see if I multiplied it back together, 9 times 5 is 45, x to the 10th times x to the first is x to the 11th, so it's equivalent. So now I'm going to use the product property of square roots on top and put my perfect square parts in the first radical. So the 9 is the perfect square number part and the x to the 10th. And then I'm going to have that being multiplied by a second square root that has the leftover parts. In this case, there's going to be a 5 and an x to the first. And don't forget that's still all over 4. So now I can evaluate 9. Square root of 9 is 3. Square root of x to the 10 is x to the 10 divided by 2, or x to the 5th. I have that is being multiplied by square root of 5x, and the whole thing is over a denominator of 4. And that will be my final answer.